Kia ora. Let's see how we can use the ions to work out formulae and equations. So my first example is a precipitation reaction of calcium chloride reacting with silver nitrate to form silver chloride and calcium nitrate. You'll notice I've just simply swapped the anions so that the chloride goes with the silver and the nitrate goes with the calcium. So how did I write these formulae? So if I look at the table of ions, so I've just got it visually represented here. Calcium is Ca2+. So you'll notice when I combine it with a chloride, chloride is just simply Cl-. So in order to balance the one negative charge with the two positive charges on the calcium, I am going to need another chloride. And that's how I get CaCl2, because I have two chlorides. The little 2 on the right of Cl means I have got two chloride ions. Those little subscript numbers only apply to something that's immediately to the left of it. So it only applies to Cl. It does not apply to Ca. So I've only got one Ca. Now similarly for silver nitrate, if I look at the table of ions, it's Ag+, and if I take a nitrate, it's NO3-. So I've got one nitrogen and three oxygens, all with a total of one negative charge. So in order to balance out the one positive, I need one negative. So it's just simply AgNO3, one of each. So to write silver chloride, I will write Ag, and because it's only one positive and chloride is only one negative, I only need one of each, so it's just simply AgCl. Chemists are lazy, we never write one, so we don't write Ag1Cl1. It's just simply AgCl. Then similarly for calcium nitrate, because it's two positives and nitrate is only one negative, I am going to need two nitrates. Now to show the two nitrates, remember those subscript numbers only apply to something immediately to the left. So we put brackets in, because if we don't have the brackets, it's going to look like NO32, which is not correct. So we put the whole NO3, so all of NO3 in the brackets and the 2 just immediately to the right of it, so that the 2 applies to all of NO3. It does not apply to calcium. Now we've done the formula writing and we know it's correct. Now we balance. So you'll notice I have one calcium and one calcium, so that's fine. But I've only one chloride on the left side of the arrow. But I've got two chlorides on the left side of the arrow and only one. So I am going to need another chloride. But I can't just write a chloride by itself. It's got to have the silver ion with it. So I now need two silver chlorides. The 2 in front means it applies to everything after the 2. So it applies to both the silver and to the chloride. Remember, the subscript only applies to something immediately to its left. The big numbers in front apply to everything afterwards for that formula. And now I have, because I've got two silvers, you'll notice I need two silver ions on the left as well. So when I say left, I mean left of the arrow. And so I also need two nitrate ions because I have two nitrate ions there. So in order to balance, I put a 2 in front there. And the 2 means I've got two silver ions and I have two nitrate ions. So hopefully that makes it easier to show how to balance equations. For calcium, for this next reaction, which is not a precipitation, it is a displacement reaction. You'll see that I've got a metal with something that's soluble in solution, and I form a metal and something soluble in solution. So to show my calcium metal, I've got my calcium ion, but these little gold triangles are my electrons. So when I react it with silver nitrate, as I did over there, so I'm not going to show that again, I am going to have a reaction where the calcium gives away its electrons to form a calcium ion. So I'm going to have a calcium ion on this side. So you see it's lost these little electrons. and what's gained it is the silver. So one of those electrons will go to one silver atom, but I need the other electron to go somewhere as well, so it's got to go to another silver ion to form another silver atom. So I've got here a calcium atom with a silver ion. Now I'm forming two silver atoms and a calcium ion. So you'll notice in order to balance, because I now have got two silver atoms over there, I need another silver ion, which of course has to have its nitrate, and therefore to also make my nitrate over here as before, I need two nitrates, giving me CaNO3 with brackets and then a 2. So I've got to show my two silver nitrates and my two silver atoms. So I write the 2 in front there and the 2 in front over there. So notice this is not an ion, it is an atom. It's got its full electron complement. It hasn't lost or gained anything, but during the reaction it loses those electrons to form the calcium ion. The silver ion was short of an electron and it takes it from calcium. So you'll notice, although I've got a charge here because it's showing the ion, but plus an electron, so there is no charge over here. You might ask, why haven't I shown charges over here? It's just simply because in the compound, the two positive charges on the calcium are cancelled out by the one negative charge from the two of each of the two nitrate ions. So lastly, the other two types of reactions is potassium plus chlorine to form potassium chloride. Hopefully you'll recognize this as a combination reaction where two elements form one compound. So we have my potassium atom. I've already balanced this. So my potassium atom, so my K plus an electron. Now this can look a little bit confusing because this is not really an ion. This is a molecule. It's a covalently bonded substance. So we don't have ions here. So it actually does not have extra electrons. It was just a bit difficult to show this. So I'm trying to show it's basically like that. I don't have any extra electrons. This is actually not negatively charged. So when my potassium reacts, it now gives its electron to each chlorine atom in the molecule to form the chloride. So this actually, as I say, is just Cl and Cl. There's no ions here. And if I have another potassium atom, it'll give its electron to the other chlorine atom to form the chloride ion. So please learn that diatomic gases, they're sort of like an upside down L. So it'll be like N2O2 F2 and then going down in group 17, the F2Cl2 Br2 I2. So please learn those. You just need to know it. And then of course H2 is the other one. And lastly, the last type of reaction is your decomposition, where you have, for instance, calcium hydroxide. So it's my calcium ion, OH minus. So I need two of them. So it's Ca bracket OH2 forming calcium oxide. Again, from the ions, it's Ca2 plus and O2 minus. So I just need one of each. And then, of course, it forms water. So in decomposition, you pretty much always form the oxide. So calcium carbonate would form calcium oxide plus carbon dioxide. Calcium hydroxide will form calcium oxide plus water. So if it was a carbonate, it forms carbon dioxide. If it's hydroxide, it tends to just it forms water. And in each case, you get the